Hello, my name is Kristina, and I did this research with my professors Jelena Laborec and Ivana Grčić. Today I will talk about our work, which is based on solar photocatalysis. Actually, we are trying to purify water after wastewater treatment. Someone will ask, why are you doing this and spending extra money if there are some water treatments? So I will say there are some chemicals which are very small, and commercial wastewater treatment cannot remove them all from water. So for the beginning, I'm a PhD student and research assistant on European project, which started 1 year ago on Faculty of Geotechnical Engineering. We are from University in Zagreb, but our faculty is based in Varaždin. The aim of our project is to make solar photocatalysis the fourth stage wastewater treatment. Also, project is based on the principles of the circular economy by production of carbon nanotubes from waste. So, as I say on the beginning, this work presents application of solar photocatalysis in surface water after wastewater treatment plant. As you can see on this figure, micropollutants often lack in wastewater and they are being released in surface waters. Solar photocatalysis then is performed under the influence of radiation energy from sun or artificial UV radiation. Solar photons are directly absorbed by reactants and the catalyst causing a reaction. In our case, catalyst is titanium dioxide. Then highly reactive hydroxyl radicals are formed, and in ideal case, organic compounds are completely mineralized with the formation of carbon dioxide, water, and mineral acids. Some people will say, but carbon dioxide is greenhouse gas. What about that? Yes, it is, but I'm producing more carbon dioxide by talking during this presentation than in 1 hour of solar photocatalysis. Micropollutants, they are widely present in the aquatic environment due to their use in agriculture, industry, and products for human consumption. In this figure, we can see sources of pharmaceuticals and their related metabolites to surface waters. They are subjected to natural transformation and removal processes in the environment based on their hydrophobicity, biodegradability, and the environmental conditions, and which explains their presence at trace levels in water sources and drinking water. Surface waters in Croatia are divided into two basins. First one is Danube Basin, which is marked as HRC, and Adriatic Basin, HRJ. Chemical condition of surface waters in Croatia are shown in this figure, and is based on the latest assessment of Croatian waters. It shows that 92% of water bodies has good chemical condition and 8% have not achieved good chemical condition. So on our project we will try to make it even better. This table shows main groups and substances from the second watch list, their maximum acceptable detection limits, and monitoring results from Croatia. There are endocrine disrupting pharmaceuticals, estrogens, estrone and 17-beta estradiol. Then one synthetic estrogen, it is 17-alpha adenyl estradiol, which is used as hormonal contraceptives, and it causes feminization of male fish. And that was one of the first realization of the harmful effects of hormones on the environment. There are pesticides. Pesticides are also one of the relevant chemicals which are present in European surface waters. After application on the field, pesticides contaminate surface waters by drift, runoff, drainage, and leaching. And meanwhile, they undergo degradation by hydrolysis, oxidation, biodegradation or photolysis. And for some compounds, degradation products can be present at greater levels in the environment than the parent pesticide. There are also pharmaceuticals, antibiotics, and macrolide antibiotics, which have significant effects on humans and development in general, but their retention in aquatic ecosystems already shows negative impacts on human health and on other species. And there is also one insecticide, metaflumizone. Last column shows expected results after solar photocatalysis. All is zero because results of solar photocatalysis from our lab are very promising. And here we have results. So in this paper, the curing concentrations of certain substances in the surface waters of Croatia are investigated. In the next few slides, you can see preliminary results of solar photocatalysis of target compounds. Here we have results of diazepam. You can see that concentration of diazepam was decreased for 40% after 90 minutes of photocatalysis. In case of diclofenac, concentration was decreased for 10%. Here we have enrofloxacin, which concentration was decreased for 20%, and ibuprofen with 30%. And the last two were 1H-benzotriazole, which concentration was decreased for 30% after also 90 minutes of experiment, and imidacloprid, which concentration was decreased for just 2%. So by the results, imidacloprid is most persistent pollutant in this work. It is necessary to improve conventional methods of wastewater treatment to reduce the concentration of new pollutants in wastewater. Our emphasis is on pollutants from the second watch list, so we have ongoing research which include analysis of byproducts by QTOF, pilot-scale experiments, and kinetic studies by solar photocatalysis. Finally, it is worth to mention the risk value of using these substances regardless their influence of environment. Solar photocatalysis presents the alternative technology for complete degradation of pharmaceuticals in situ in surface waters and minimizing the possible risk. So thank you very much, and we are open for questions. Thank you.